So if you remember, what were we doing last lesson?
Integration.
Integration. Now, what was integration all about?
We were finding the area of a line. Line, I mean like a function.
Yep. So it's to do with finding the area underneath the curve, between a curve and the x-axis, right? Good, absolutely. And we basically said, this was my function, okay? And the way which we thought about this is as infinitesimally thin rectangles, one after the other, yeah? And it's just going to basically be the height of that rectangle times by some infinitesimally small width. And of course, you're going to sum those for as long as you need. Hence, we write it as an elongated S, a sum, all right? Good, but we also said that integration was the reverse of differentiation. So we literally thought about it like that for how we integrate a function. So what would the area function be for the integral of x to the power 4 dx? What's the two steps that we need to do? Good, so first of all we add 1 to the power, then what do we do?
Divide by the power.
Divide by the power. That's simply the reverse of what we needed to do, right? Sorry, Rishin, could you pass me the rubber? Thank you. Yeah, so it's literally just the reverse of differentiation, where you would bring the power down, then reduce the power by 1. It's the reverse process. But you're absolutely right, you need to add some constant. Just remind me, why do I need to add a constant here?
Because it's something to do with finding the area. There will be, some kind of area that is so small that it cannot be calculated, but something like that, or? Not quite. Sophia, you were going to say something.
Differentiation, the constant will be of 0, but you have to represent.
Absolutely right. So just thinking about the fact that integration is the reverse of differentiation, okay? If I took this function and differentiated it, I should end up with x to the power 4. But of course, there could be some number there, because if I differentiate a constant, that will just go to 0. So it's got to be x to the power 4 plus 0. I need to represent that in some way. Does that make sense?
Yeah.
Good, fantastic. Okay. Now, what is this function over here? So in terms of my area, would you be happy that thing there would be my area function? Okay. In other words, it finds me. So if this was my function, so it's x to the power 5, so let's say it's something that looks like that. Okay, that's my function. And let's put on some axes. Okay. What this function would do, when I stick a value into it, it would find me the area underneath that curve up until that point. So if that's my point that I stick into this function, it gives me the area from negative infinity up until that point there. Make sense? Right? Good. Okay, fine. So what about the next one then? What about this one? What would the integral of x to the power 7 plus 5 be? But this time we're doing it between negative 3 and 1. So what is the integral, first of all? What's the area function?
X over 8 divided by 8 plus 5x.
Plus 5x plus c, okay? But the only difference here, though, is we need to take it a little bit further, because we're actually telling you some values to find the area between, negative 3 and 1, okay? So which value do we stick in first?
1.
It's the 1, right? We need to find the area all the way up until 1, okay? So we stick 1 in here, okay? And then you're happy you need to take away the area up until negative 3. Does that make sense? Because in other words, you're finding the area up until like negative 3, and you need to get rid of it, just to be left with the area which you want. So you need to take it away, all right? So we go negative 3 to the power of 8, all divided by 8, plus 5 lots of negative 8, plus c. All right. Does anybody stick this in a calculator? Does anybody work it out? I can't be bothered. It's
Minus 800 or something?
Wait, what? Was it minus 830? Okay. Right. Now, it came out as a negative number. Can anybody think why? Yeah, so I'm finding the area underneath the curve. Go on.
Yeah, under the x.
Right, exactly. So in other words, my function between these 2 points clearly just went underneath the axis, underneath the x-axis. Hence, the area becomes negative. Okay? Hence, the area becomes
So it's a vectorial property.
Yeah. So if it comes out as negative, it just means you're finding the area underneath the curve. So the curve is underneath the x-axis. That's all it means. Okay. Good. Let's try this one then. Okay. Now here, can I just integrate it directly?
No.
Why not? What did you say? Go on.
Just repeating the word.
Why can't you integrate it directly?
Because the.
Hang on, Adele.
No.
Yang's going to answer.
Sorry.
Shouting's next if Yi Yang can't. Why can't you integrate this thing directly?
Why?
Yeah,
Why?
that's the question.
Can I say I don't know?
No? Give me an answer.
Uh,
This thing you can rewrite as x to the power half. Absolutely, I'll take that. Good, I'll let you off the hook then. Xiaoting, why can't you just integrate that directly?
We need the up and down need to multiply the x of power 1 over 2.
Kind of. You need x to the power of something, don't you? Whereas this is just a fraction. This is a fraction. So you need to rewrite this thing so you've got terms with x to the power of something. Happy with that? Well, are you happy that this thing literally just means take take the first term divided by x to the power of half and add it to 4x squared divided by x to the power of half?
Yeah.
Happy with that? Yeah? Okay, so in other words, you get the integral of 1. Well, x to the power of 3 divided by x to the power of half. What's that the same as?
X or 3
4.5.
It's 2.5, so 2.5, which is...
minus 2 over 3.
No, 4 over 5.
What's 3 take away half? 2.5, which is as a fraction.
1.5.
As a fraction,
5 over 2.
Yeah,
Good.
5 over 2.
5 over 2, good. Glad we're awake. Okay, plus
Gosh.
4x squared, and if you divide that by x to the power of half, what do you get?
1 over 2.
So 1.5, which is 3 over 2, did you say? Good, excellent. 3 over 2. Okay, now we're in a position where we can actually integrate, because you've got x to the power of something. We didn't have that at the start, we've got it now. All right? So, running out of space a little bit, let's see if we can squeeze it in. Okay, what would the area function be? So it's going to be x to the power of, raise the power by 1, you get 7 over 2, good. Then you need to divide by that power, so it becomes that. Okay, plus, and then you get 4, 3 over 2 plus 1 is? Good, 5 over 2, and then you need to divide by that, hence it becomes 8 over 5. Okay, plus c, of course, between 0 and 1. Okay, now, by the way, I will just mention this now. I always write the plus c in, because it's illustrating what happens. Okay, so if you're not sure, you can write the plus c in, but can you see when you're calculating this thing, when you actually stick limits in, you don't actually need to put the plus c, because the c's just end up cancelling anyway when you end up taking them away. So if you want to, with a definite integral, so this thing here is called a definite integral. In other words, it has limits, it has values that you actually need to stick in. So you're finding the area between 2 points, okay? Then you don't have to worry about putting the plus c in if you don't want to, okay? Whereas this thing, if it's not a definite integral, it must be a indefinite integral. In other words, there's no limits that we want to find the area between, okay? Or I guess you could say the limits are negative infinity to infinity if you wanted to, okay? Then you would need to put the plus c, okay? So if you're in any doubts, put the plus c in and you'll be fine. However, if you want to streamline the process slightly, or if you're used to not putting the plus c in if you've got a definite integral, then it's fine to leave the plus c off. Is that okay? Good, fine. All right, fine. So yeah, we stick 1 in, then we stick 0 in. So let's see what we get. So we get 2 times by 0 to the power of 7 over 2 divided by 7. Sorry, what am I doing? Put the 1 in first. Plus 8, 1 to the power of 5 over 2 over 5. And then you need to take away the same thing when you put 0 in. So 2 lots of 0 to the power of 7 over 2, all divided by 7. Plus 8, when we put 0 in, 5 over 2 over 5. What do we get? What do we get, somebody? I mean, you get 2 sevenths plus 8 fifths, right? Which is... what do we get? 35, 35. That's going to be 7 times 8, which is 56. And then that's going to be 5 times 2, which is 10. So it becomes 66 over 35. Yeah? Happy with that?
Yes.
Good. Of course, you've got a calculator, you can do it yourself.